Alright, so then we're looking for u dash and v dash. U dash, now sine behaves itself, so it just goes to cos x. Cos is trying to trick you, because it's trying to trick you, so v dash is minus sine x. And now we start putting it together. So we want u dash v minus v dash u. So u dash v looks like this. Cos times cos. Do you guys remember how you write cos times cos?
Cos squared.
Yeah, you put the 2 in a weird place. So it's cos squared x. Huh? Pretty much. Alright. Fancy pants. What comes next? This times this, and because it's minus in the quotient rule, and because the minus there's going to be a plus. So plus sine squared x over v squared, v being cos, so cos squared x. And that is so far our dy dx, but it's a little messy and there's a simplification we can make.
The top equals 1 squared, which equals 1.
Yes, this is 1.
Why?
Have you guys seen that before?
No.
Alright, remember the unit circle. This is a unit circle, has a radius of 1. If we draw a line anywhere in it and drop a point down, this is cos x and this is sine x.
Oh my god.
And it's a right angle triangle. And this is 1 because that's its radius. So using, we're feeling like Pythag coming back to haunt us. Pythag would say that this is A, B, and C.
Oh, yeah.
And therefore, cos squared x plus sine squared x is 1 squared or just 1. And if you want to convince yourself of this, choose a value for x, put in 40 and 40, and it will come out to be 1. This is an idea, we don't have to know many trig identities, but this is one that you guys are just expected to know. And it will come out rarely, but it might come up. So cos squared x plus sine squared x equals 1. Therefore, the derivative of tan x, dy dx, is 1 on cos squared x. And because we write 1 on cos squared x so often, we give it its own little thing, it's sec squared x.
Why don't they just...
I know, it's great fun. Sec is the same as 1 on cos x. So sec squared x is 1 on cos squared x. Not that you're likely to see it, but CSCX is 1 on sine x. Unlikely to see it, you're more likely to get sec. Don't know why they called it sec. It's also why in your notes, oh no, it's not there, but you might see this written as sec squared x rather than 1 on cos squared x.
If we're simplifying it, do we have to go the whole way to sec squared x?
No. Leave it there.
That's okay?
Yep. Yeah, that's far more useful than anything else. Alright, so with this, the chain rule still functions. So, if we're looking to differentiate the sine of a function, we know that sine differentiates the cos, and by the chain rule we throw out the derivative of the inner function. Quite often you'll see that derivative written in front of the cos, just because it lands there much more neatly. Something with cos, cos differentiates to minus sine, and the function stays the same in there, multiplied by the derivative of the inner. Similarly with tan, tan is 1 on cos squared of the function, so 1 on cos squared of the function, multiplied by the derivative of the inner. So when you differentiate a trig, you're going to throw out a different trig, and quite often use the chain rule. And then of course all of these combine with product, quotient, and other chain ones. Which is why we do some practice. So, you guys turn over your page. Yep, this is what you want to do after lunch.
Question isn't even the same.
It's not even the same? Did I mess it up? What does your question say?
2 sine x.
My bad.
That's a mentos.
It is amazing.
Alright, so yours is 2 sine x, is it?
Yeah.
Alright, 2 sine x, take 4 cos, cos x. Alright, if this is y, anything connected with plus or minus, we just treat separately. So really, we're treating this as 2 separate problems. This bit and that bit. dy dx is the 2 stays, sine just switches to cos, so this becomes 2 cos x. Nothing too bad. The minus 4 stays, not entirely, because the cos is going to switch to a minus sine. Plus 4 sine x. So we're doing each separately. And if you want to make a note to yourself of what happened to the negative, then go for it. But hopefully you'll remember what happened. Alrighty. Y equals x cubed tan x.
It's squared on ours.
Seriously? You think I'd get this easy, right? All I had was this on one screen, and then I was typing your notes up on the other screen.
I reckon you just got mixed up with 2s and 3s.
Yeah, I reckon you probably did as well. Alright, x squared tan x. Any idea which set of rules we're going to use?
No.
Product, yes. So I'd be thinking our u is x squared and our v is tan x. Our u dash therefore is 2x and our v dash is 1 on cos squared x.
That just sec thing.
Or sec squared x, yeah. But I would write 1 on cos squared x.
Okay.
Alright, then we're going for product rule. So product rule is u dash v plus v dash u. So dy dx is u dash v 2x tan x plus the multiple of these, so x squared over cos squared x. That's alright, isn't it? Yeah. So, it's using the rules we've done before with our 3 new tricks of differentiating. Yeah. Alright. Looking at this one, we're probably thinking quotient, because it's set up as a nice little fraction for us. So our u is going to be cos x, and our v is 1 plus sine x. Alright, now if we differentiate, u dash is minus sine x, and our v dash is just simply cos x. The 1 is a constant, so it differentiates to 0, sine differentiates to cos. Then the derivative is u dash v take v dash u over v squared, and it's a matter of substituting. So u dash v is minus sine x bracket 1 plus sine x. Take v dash u, so take cos squared x over 1 plus sine x squared. Now, you'd be completely okay to leave it there ordinarily. I'm going to aim for a simplify, basically. Because you will have to do some playing with Trig, so we might as well start now. To simplify, I would throw this in. And therefore what we're going to have is minus sine x minus sine squared x, because that's the sine and sine there, minus cos squared x over 1 plus sine x squared. Alright.
Why is it?
Why can't you just square the bottom?
I don't want to yet.
Oh, okay.
As in, you mean expand it out?
Yeah.
Yeah.
So what's the minus cos squared? It's going to be plus cos squared. Please, name plus name.
Because it's here, quotient rule has the minus already. So it's that cos and that's cos and that's, so that's where the minus has come from.
Yeah.
Yeah, okay. And then let's look at the top. So I'm on the top going to factor out a minus 1. Minus 1 lots of sine x. And can you sort of see what's going to happen? If that becomes a positive and that becomes a positive, what is this positive version? It's 1, yeah, we've seen it before, and it will keep coming up. That becomes 1, so really if I'm factoring out minus 1, I can add in here a plus 1. And that might take a little, okay, I'll write an explanation off the side. Over here, it's minus 1 sine squared x plus cos squared x. If I take a minus out of all of that, that's what's happening. And so really, it's minus 1 lots of 1.
Why is it minus 1?
Because I've factored out minus 1
Oh, yeah.
from there and there,
Yep.
which has made it pluses, and I needed the pluses to get there. Alright, now this is the reason, so I didn't expand on the bottom, because it's going to get useful in a sec. 1 plus sine x squared. Are you guys happy that sine x plus 1 and 1 plus sine x is actually the same thing? Meaning what I can do is I can cancel this with one of the factors down there, and the overall answer is simply minus 1 over 1 plus sine x.
That got so simple.
It got really nice and simple. And this is part of the beauty of it. You'll start learning a few of these little tricks to simplify it out. And there's really only 2 tricks you need to know. One is this one, and the other is tan equals sine on cos. Or, this one's probably worth mentioning. Can anyone guess what 1 on tan
That's not on
is?
the camera, so.
1 on tan x is cos x on sine x. It's the inverse of tan, or tan upside down,
Oh, yeah.
so we flip it, right? And then, so regular tan is tan sine on cos, 1 on tan is that. What? Alright, get a little more complicated.
It's fine, yeah. It's a day thing.
So, in this case what we're looking at is y equals sine of some function of x. And therefore to differentiate it, the derivative dy dx will be cos of that same function of x multiplied by the derivative of that function of x. So by the chain rule we're going to throw it out, and you wouldn't normally write this line. This line's not needed if you're sort of confident and had a bit of practice. But I'm just putting it in there so that we're a bit happy with where this is going. And you remember how I mentioned that quite often this actually lives there. The reason it lives there is because I could write cos 4x squared plus 7x multiplied by 8x plus 7. The problem is it all looks like it's attached to the sine if I tack it on the end here, or if I tack it on the cos here. So I'm going to put the derivative in front. So when I differentiate this, it's going to be 8x plus 7, lots of cos 4x squared plus 7x. And that's this f dash x landing in the front. Yes?
Do we have to simplify this kind of stuff then? Can we?
I mean, all you could really do is distribute this in, so you have 8x cos of that and 7 lots of cos of that, and even that's not much simpler. So no, we're just going to leave that there.
Cool.
Tan of sine of x. This feels like it should be simplifiable. Alrighty, so the plan is we're differentiating the tan function, and then we're multiplying out by the derivative of the inner function. So, for dy dx, the derivative of tan is 1 on cos squared x. So here it's going to be 1 on cos squared sine x. Multiplied by the derivative of the inner function. So it's simply cos x. And if you're looking at answers or solutions, quite often this cos x would simply live on top where the 1 is. A note on simplifying, you can't cancel this cos x with anything down here. If this was a cos x on the bottom and a cos x on the top, then you can cancel. If it was a cos sine x on the top and a cos sine x on the bottom, then you can cancel. You can only cancel trigs if what they're being applied to is the same. So these are different, and they're not like terms, and you can't cancel them out or factor
Is
it.
it like the inverse of tan?
No, not like that. Yes?
Why is it 1 over cos squared with no x at the bottom?
I guess there is an x, but it was whatever is in here.
Okay.
From
It's being applied to sine x and cos
here.
squared.
So the tan of x is 1 over cos squared of whatever was inside. So in this case, the sine x.
Okay, thank you.
Multiplied by the derivative of that inside bit, which is there. And it can either live out there or up there. I just like putting it at the end because I think it's more obvious. Alrighty. And that will give you enough to get started with. Don't do all of question 1, 2, 3. Do the odds to jump through, and then go on. And if anyone's done 2G question 6, it's particularly weird. So if you do get stuck on that one, I know it's the previous one.
Please, you show me how to do it.
Yeah.
I am dead.
There is a by hand way, which I'll show you. Yes?
Then you showed me how to do that question with a calculator, but